How are you, my friends? This video is presenting 8 old exams questions related to graphs and circles. These questions came from the lectures 19 and 20 in the Algebra course. Please, you can visit any lecture in Algebra course in the playlist called Algebra Course Lectures. Let's start question number 1. Given the circle, not easy circle, the center is Mn and the radius is R. Let's find m to the power minus 1 minus n to the power minus 1 all to the power r. Well, it's a little complicated, but we can do it. See, the important thing in the equation of a circle, we need to complete the square. You know that. If you want to try it again, you can try now. And let's see the solution. Since we have here half, we have to leave 1 in the coefficient of x squared and also y squared. These should be the same number in a circle. If these are not the same, it's not a circle. So multiply the given equation by 2. So this x squared becomes 1. See, this is x multiplied by 2x over 2. I put all the x's together. Multiply here by 2. So this is the same, half x squared or y squared over 2. Just different way of writing. Also, x over 4, 1 over 4y. Multiply by 2, so x over 2. And here multiply by 2, half y. Multiply by 2, 1 over 8, take it on the other side. Now we don't care about these fractions, remember. We care about the coefficient of x squared, the coefficient of y squared. Now remember completing the square. If you need to see completing the square in details, please go to lecture number 20. So we take half here, because it's already half, and we have to take half of it, which multiply by half, 1 over 4, square it, 1 over 16. So I add on this side 1 over 16, on the other side 1 over 16 with this blue color. Same thing here, half y, I have to multiply by half, 1 over 4, square it, so 1 over 16, 1 over 16. The first one for the x, the second one for the y. Now remember, you have a squared here, minus 2ab plus b squared is equal a minus b squared. This is what we call perfect square. So you take the square root of the first one, the square root of the last one, and the sign in the middle here. So this will be 1 over 4, remember? So let's continue on the next slide. Now this is the equation from the last slide. So it will be x minus 1 over 4. See, there is a minus here. And this is the square root, 1 over 4. There is a plus here, so I put plus. And this is 1 over 4 also. So I add the other numbers, 2 plus 1 plus 1, 1 over 4 altogether. Remember the equation of a circle. I just put here a small equation here. You can remember x minus h. So this is 1 over 4. Y minus k we have in the formula. So k will be minus 1 over 4. R squared is equal 1 over 4. Remember, r squared is equal 1 over 4. So when you take the square root, it will be r equals half. So these are the numbers, r half, the h, the m here, which is h, m 1 over 4. And usually we call this k, which is n. So we have m, we have n, we have r. Remember, what do I need in the question? M to the power minus 1. So 1 over 4 to the power minus 1, which is 4. See, 4 minus, this one also to the power minus 1, minus 4. So 4 minus minus 4 is 8. To the power r, which is half square root of 8, simplify the final answer to square root of 2. That's a big story, I know, but just be careful about numbers. Question 2, let M be the midpoint of the segment joining A and B. So we find the midpoint easily. This is M. Find the equation of a circle whose center is M and passing through the point D minus 3 and 2. See, we have 3 points. Maybe you are confused or something. What do? Advice. I gave you an advice in lecture 20. The advice is make a sketch. Make a sketch. So you have A, see this is A, you have B, and you have the midpoint. and there is a circle in the center here, the midpoint, and then passes through. So D minus 3, 2 passes through. It is on the circle. Remember, the question here did not say the circle passes through A and B. The question did not say the circle passes through A and B. Okay, so let's find the midpoint now of A and B. X1 plus X2 over 2, you know the formula. It will be minus 5 and 6. You can check the numbers, please. Okay, so this is H and K. And the distance now, we need from M to D. That's the radius. See, the radius is equal to the distance from M to D. Also by the distance formula, I put here the distance formula for you. It will be square root of 20. Put everything in the equation of a circle. That's H and K, so X plus 5 squared, Y minus 6 is equal R squared, 20 only. That's question 2. Question number 3, very nice. I gave you the x-intercept and the equation. Give me the y-intercept. So it's 50-50. Now, remember in the equation here, usually we have x and y for sure, but we have a k. That's the problem. You have to find the value for the k. So what do you do? The trick? The x-intercept here, 9, 0. This is x in the 9, so I go there 9, and 0 in the y here. See, because x-intercept is a point on the graph. So I take x9 here and y 0. Then I solve the whole equation for k. Then to find y-intercept, let x equal 0 again. Big nice story here. So this is the equation. This is the x-intercept, x and y. See, 9, 0. So this is, I put where? 9 here. See, 9 here, 0 for the y. So that's 2. And this one, 9 minus 1 is 8. Cube root of 8 is 2. So 2 plus k minus 3. Simplify inside, k minus 1 square. You square it. So that's 4 is equal k minus 1. So k will be 5. Now this is k, remember. So I put k5 again, k5 in the equation. So this is k here. You see k5, that's k there. It will go down 5. I need y-intercept, let x equal 0. Just put 0 here. Cube root of minus 1 is minus 1. Plus 5 minus 3. So it will be 5 minus 4. That's square root of 1 is 1. Take 2 on the other side. So y will be minus half. So y-intercept will be x0 minus 1 over 5. Minus 1 over 5 is. Okay, question number 4. Study the 3 types of symmetry. That's a nice equation. It's not easy equation. And I think symmetry is lecture 19 in the algebra course. Lecture 19. You can go please and check if you want to see more examples, 4 or 5 examples like that. Here, to check the symmetry, there are 3 types. We check on the x-axis. So I put everything in details here. Replace y by minus y. That's the symmetry. So every y here, see this y and this y, I put minus y. Then I simplify the equation. Minus 5 all squared. Minus, see this is minus y cubed, and there is a minus x. I don't touch the x now. So this one is not the same as this. You see, we have 2 minuses here, and here we have 1 minus. If you want to take a minus, you cannot take it out. You can take it inside the absolute value here, inside, you see? And this is absolute value of minus 1, so it becomes like that. So this one here is the same as this one. So it's not the same, not symmetric with respect or about x-axis. Check the y-axis. Replace x by minus x. So I replace every x here with minus x. And then this becomes 4. This is minus. You see the odd here, minus 5 power 5 is the odd number, so minus x with the minus becomes plus. This one also not the same here, not symmetric. Now if you check the last one, the symmetry about the origin, the answer is yes. I put all the details for you here. you replace both x with minus x, y with minus y, or put everything minus, 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 minus. Everything you have to put minus. Simplify it. This is even, so 4. This is even, also 2. This is odd here, minus, and this is a plus. Take a minus 1. See, take a minus 1. This becomes y cubed minus x power 5. Use this formula, absolute value of mn, absolute value of m times absolute value of n. Now this m and n, I put here in our question, it's minus 1 for the m, and the n is all this, y cubed minus x power 5. So this is a 1, it will go, and this one becomes again the same equation, you see here? So that's symmetric with respect to the origin. Question number 5 is easy, I think. Maybe the first one you have to be a little careful. Find x-intercept and y. We know this story. X-intercept, let's go in the first one. X-intercept, let y be 0. Just put y 0 here. So 0 minus 1 squared, that's 1 over 4 here. Take it on the other side, becomes 1 minus 1 over 4. And this is 4 over 4, so 3 over 4. Multiply by 9 this equation here. So x squared becomes 27 over 4. Take the square root, plus or minus 3 square root of 3 over 2. So we have 2 x-intercepts here. So x-intercept y will be 0. Now the y-intercept, put x equals 0. So all this will go here, it will disappear, 0 over 9. So y minus 4 squared is equal, y minus 1 squared is equal 4. Take the square root, this is a power equation. Y minus 1 is equal plus or minus 2. So the y-intercept will be 0, 3, 0, minus 1. Easy, easy, easy. The second one, oh, strange, the second one. xy equals 7, no x-intercept, no y-intercept. Because if you say in the x-intercept, let y 0, see, put y 0 here, you get 0 equals 7, not correct. 0 equals 7, you cannot reach, no value for x. Y-intercept, let x equal 0. 0 equals 7, also not correct. We can say also impossible. No y-intercept. So we can have a graph. We will graph this later in the algebra course. Later we will graph it. No x-intercept, no y-intercept. Now this one, also in lecture number 20, we did so many examples here. Determine the type. By looking here, you might say this is a circle, or this one is a circle. See, it looks like a circle, but maybe a circle, maybe not circle. So what do we have to do? The trick here is to complete the square. Let's go first one. Complete the square directly. You know how to complete the square. Put all the x's together, put all the y's together. Make this one, the coefficient here is 1. It's already 1. So when you do everything, you get 9 here. So this number here is positive. So that's r squared. So r will be 3 only, and the center will be 3 minus 5. So that's a circle, yes. So this one is a circle. Now you will try the second one. You can try it. Something, not circle. So you do the same completing the square. Same completing the square. We get minus 4 here. Check the numbers, please. Minus 4. So minus 4, this is m. We call it m in lecture number 20. So this is a minus. So the graph is non-existent, or we say no graph. So if somebody say graph this, the answer no graph. Simple. Number 7, also easy, I think. Find the equation of a circle that's tangent to both axes that lie in the third quadrant and having a radius square root of 2. So you have to make a little sketch to understand here. Only the radius is given. Tangent to both, remember. So this is tangent here to both axes. You see in the graph, this is quadrant 3. In quadrant 3, one thing we have to know important is negative x, negative y. See, that's the whole story. So this is h and k. The center here is a minus. This is the radius. This is the radius. We know the radius is positive number, square root of 2. But in the h and k, we have to put negative x, negative y. And since it is tangent, so the radius is the same as absolute value of h, absolute value of k. So now put it in the equation here. X minus, and there is a minus, all squared. Y minus, there is another minus, squared. Square root of 2 squared. Look at the final equation here. X plus square root of 2 squared, y plus square root of 2 squared is equal to 2. This is the circle here. That's the equation of the circle. The last question is the graphing, sketching. See, there's a big difference between 1 and 2. I put this on purpose. 1 square root with power here 1, 1 square root with power x2. Now to start graphing here, question 8.1, let's find the x-intercept. X-intercept, let y equal 0. I put here 0 equals minus 2 square root of x plus minus 1. Take 2 on the other side and square both sides. So x minus 1 will be 4, which is x will be 5. So 5, 0 here is the x-intercept. Just imagine that point. Remember, when you have anything with the square root here, x minus 1 or any, we call this radicand. To find the domain, remember we have mentioned domain in Algebra Course Lectures. Domain, you have to find all the values under the radical should be positive. So x greater than or equal to 1. So we start from 1. The graph will start from 1. If you put 1 here, see 1 minus 1, 0. So 1 goes to minus 2 here. See this point? If you put 1 here, you cannot put 0. Put 0 here. Square root of minus 1, undefined. So there is no, the graph will not go to 0. It will start directly from the 1. Let's go to y-intercept. Let x equal 0. No y-intercept, you see? No y-intercept. Let's take extra points here. Take any point that's easy to find the radical. 2, put 2 here. 2 minus 1 is 1. See, that's 1. And you have a minus 2 there, so it's minus 1. So 2 minus 1, this is the red point. You can take any nice number, then you can find the graph is like this. So we call this half parabola. You want to try second one. Second one is very nice. We have a squared under the radical. Completely different. Now let's find x-intercept. Put y0 here. See, 0 is equal minus this one. You square all the sides. You square it, you see? Square this, square all this becomes 9 minus x squared is equal to 0. So take 9 on the other side or take x squared on the other side. It's the same. The square root will be x plus or minus 3. So we have 3, 0 minus 3, 0. See this number here, this number there. Now the y-intercept, let x equal 0. So we have minus, square root of 9 is 3. So that's minus 3. So we have another point here. How do we know this is half a circle? See, there is a big circle here, but we take only half. How do we know? I tell you here, how do we know? One line, take the equation, this one here, and square it on the side. See, we cannot square it because when you square it, look what will happen. Square this, you get y squared is equal 9 minus x squared. Rearrange it, x squared plus y squared is equal 9. That's a circle. X squared plus y squared is equal to 9 is a complete circle. But our question is not a complete circle. Y equals negative. And the square root is always positive, so we take the negative, y less than 0. That's why half a circle. If you remove this minus from the question, you take the upper half of the circle. So this is very nice half a circle question. Now, this table here, this is only the answers of all these 8 questions. For other examples similar to these questions, please, you can go to the videos on Algebra Course Lectures 19 and 20. These questions were in lectures 19 and 20. Thank you very much for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much.